Hello everybody, we are Team NeuroX, presenting a Smart Solapur, a conceptual AI-powered smart traffic and parking management system specially designed for Solapur Municipal Corporation. Today, traffic signals are static, parking is unorganized, and emergency vehicles lose critical time. Our goal was to design a smart, scalable, and software-driven mobility solution. Solapur faces an increasing traffic pressure with nearly approximate 85,000 daily vehicles. Key challenges include static signal timings, heavy congestion near bus stands and markets, illegal roadside parking, no real-time monitoring, no predictive planning for peak hours. These problems lead to delays, fuel wastage, pollution, and unsafe roads. So we designed a smart Solapur and integrate smart mobility ecosystem. It includes AI-based adaptive signal concept, emergency green corridor model, smart parking management system, QR-based citizen alert mechanism, centralized command dashboard. To help visualize our idea clearly, we created an interactive website prototype. This website is a visual representation that represents how the system would function if we implemented. So this is our homepage, and here we can see AI traffic analysis. It visually represents the vehicle count, density percentage, and AI-based signal recommendation. For example, if one lane shows higher congestion, the system suggests extending green time. And this is a rule-based predictive model in our prototype, which can later be upgraded using the machine learning. In emergency mode, here we can see when an emergency mode is activated in the demo, the signals will turn to green for that particular lane when an emergency vehicle is detected to save their critical minutes. Our proposed workflow is CCTV will feed, AI will detect the vehicle counting and density of the traffic, and signal will adapt accordingly. This is represented logically in the prototype. In real implementation, it would use the computer vision models in Python integrated with traffic controllers. These are the following problems. Our system will help to reduce it by 40 to 50%. Heavy congestion near bus stands, railway stations, static signals, illegal parking roadside, hoppers and vehicles blocking lanes, no monitoring, no real-time traffic data or enhancement system, parking chaos, and no prediction, no planning for event, festivals or peak hours. Now let's see how AI-based adaptive signals will gonna work. CCTV camera will detect the traffic and vehicle count and traffic density on a lane. And suppose if a lane A contains 80% of traffic, lane B contains 30%, lane C contains 100% of traffic, and lane D contains 60%, then our system will automatically suggest to lane C priority, and it will extend the green signal for lane C by 15 seconds, and lane B can wait for 8 seconds extra since it contains the least traffic congestion, and lane C contains 100%, so it will give priority to lane C. Now let's move on to smart parking section. Our parking module visually represents slot availability, occupied versus free, violation marking, and digital payment concept. Here we can see red slots are the occupied slots and the remaining are the empty slots. And if you want to select the one slot, then it will show the duration for how long I want to book my parking slot, and it will pay accordingly. If I pay and book, then this slot will become mine for that particular duration of time. Here we can see I have booked slot P3 for 2 hours and this slot has become mine. And if someone violates it by parking illegally into my slot, then we have introduced a QR based alert system. This is a privacy safe concept where a QR code placed on a vehicle allows someone to notify the owner without exposing phone numbers. Each vehicles have their separate QR based and details contained in it. And when we scan the QR code, it will automatically notify to the user by alerting them, and if they are not cooperating within the time limit, then traffic police can take the legal actions. Now our last but not the least feature is command center dashboard. This dashboard is designed as a decision support interface for SMC. It visualizes active junctions, violation parking occupancy, peak hours trends, and weekly congestion patterns. Currently these are simulated dataset to demonstrate the analytic capability. Here we can see a graph. It shows the hourly traffic volume and it is showing the peak hours at which time the traffic density is high. On the right side we can see the parking slot availability and occupied and reserved. Below is the live enforcement feed, and this is the active traffic count, average delay, parking fill, and the active alerts. So the technologies we are using into it is in front end React.js, in back end Node.js, Express.js, and Python. Then database MongoDB and Firebase. APIs we are using are the Google Maps API, custom REST API, etc. And for analytics we are using chart.js, and Our system will collect the real-time and historical traffic data too to predict the congestion using rule-based logic, dynamically adjust the traffic signals timings, create a green corridor for ambulances and other emergency vehicles, manage the parking and collect citizen feedback, and it will visualize all the data on centralized SMC dashboard. Feasibility and viability of our idea. Our idea is fully feasible, fully software-based solution, no heavy hardware required, uses existing traffic infrastructure and maps, and can be implemented phase-wise. Scalable for the future smart city integration. And strategies to overcome challenges are the combined historical plus real-time data for better accuracy, simple and user-friendly citizen feedback interface, start with the manual and automated hybrid control, and continuous system learning and optimization. Potential challenges and risks are the accuracy of real-time traffic estimation, initial low citizen participation, integration with existing traffic signals, and data reliability during peak hours. Potential impact on the target audience are for citizens. It will reduce their travel time and less traffic stress. For emergency services, faster ambulance response. For authorities, better monitoring and control of traffic. For drivers, easy parking and smoother movement. Benefits of the solutions include social benefits. It will improve road safety, faster emergency response, better citizen experience. For economic benefits, it will reduce the fuel wastage, less time lost due to congestion, lower traffic management cost. And for environmental benefits, it will reduce the vehicle emission, less idle time at signals, cleaner and greener city roads. Our solution improves the daily life, saves times and fuels, and supports a cleaner urban movement. So this was the overview of our idea, and we are excited to take a smart Solapur to the final round and move one step closer to implementing it for Solapur. Thank you so much.